Example of solving a trigonomic equation. In this case, the nice thing is all the functions are in the same form. They're of sine and they're of a double angle. So this looks like a quadratic. I'm going to rewrite it as a different form, where I'm replacing the sine of 2x with just plain old a. So we're going to get 6a squared minus a minus 1 is equal to 0. And I'm going to solve this equation. It's a lot easier looking. Plus I don't have to keep writing sine 2x all over the place. So to factor this, we're going to find factors of 6 and subtract up to 1, which are 3 and 2. So this will be 6a squared. It's going to be a minus 3a and a positive 2a to come up with that negative a here in the middle, minus 1. Now I'm going to use the grouping and factoring format. So the GCF of the first two is 3a, left behind is 2a minus 1, and the GCF of the second two is just a positive 1, left behind is 2a minus 1, and yank that out and we're going to have 2a minus 1 times 3a plus 1. And I'm going to keep going. I'm going to get it all the way down to a equals. So here we're going to have a equals a half and a equals negative 1/3. Of course, that's not what I was trying to solve for. I'm not trying to solve for a. I'm trying to solve for x, which is buried inside this sine of 2x, which is what a is equal to. So what we're going to get out of this is that sine of 2x is equal to that first one. Let me go back. 1/2. And again, sine of 2x is going to equal the other one, which if I remember right was negative 1/3, but just to make sure, negative 1/3, and solve these two equations. So the question becomes, when is the sign positive to start off, and when it's positive is in the first and second quadrants. So I'm going to draw a triangle in the first and second quadrant. So put a little axes here, draw nice lines. Let's see here. We'll put it in the first quadrant, a little reference triangle, and I'll just put a line in the second one to remind myself that there is another angle. I could draw another triangle here, but I'm not going to really need it. Alright, and then let's label what we have. We have this angle, let's just call it theta for now, 2x. This theta is equal to, the sine of theta is equal to 1/2. So opposite will have to be 1. Hypotenuse will have to be 2. And that's a special triangle. That would have to be square root of 3. That makes theta equal to pi over 6. And it also makes the second angle, the larger one, 5 pi over 6. So we're getting two answers here. We're getting that 2x is equal to pi over 6, and 2x is equal to 5 pi over 6. Now because we're not sure about the interval here, I didn't say 0 to 360, but that's a general given. But either way, you should still have to add on that plus 2 pi k. So I'm going to add it on to both of them. Because it is, you know, every revolution you'll come up to another solution. Alright, so if we solve for x, we're going to get x is equal to, divide both sides by 2, we're going to get pi over 12 plus pi k. And over here we're going to get x is equal to 5 pi over 12 plus pi k. So let's just pretend that this is for all values of x between 0 and 2 pi. Well, if we let k equal 0, we're definitely going to get, you know, pi over 12. And we're going to get 5 pi over 12 over here. So if we let k equal 0, we're going to get those two answers. Now if we let k equal 1, that would be pi over 12 plus pi, which is 12 pi over 12. So that would be 13 pi over 12. Well, that's less than 2 pi. And if we let k equal 1 here, we're also going to get 5 pi over 12 plus 12 pi over 12, which is 17 pi over 12, which is also less than 2 pi. Now if we go back through and let k equal 2, this becomes 2 pi, and obviously that's going to be bigger than 2 pi, both of them. So for the sine of 2x equals 1/2, we're getting 4 answers: pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Alright, for the second part here, sine of 2x is equal to negative 1/3. Again, we're going to want to draw in our axes, and ask, when is the sign negative? Well, the sign is negative in the third and the fourth quadrant. So I'm going to draw this so that we have large third and fourth quadrants. And I'm going to put the main angle in the fourth quadrant. Oop, wrong color. So I'm going to put the reference triangle in the fourth quadrant. And then I'll just draw another line in the third to remind myself that, yeah, there is a third quadrant angle that's associated with this sine of 2x equals negative 1/3. And if I label my sides, we're going to get opposite is negative 1, the hypotenuse is 3, and this is not a special triangle. So we're going to have to use the calculator. So again, this is theta, and we're going to find theta is equal to sine inverse of negative 1 over 3. And that's the main reason that I put the main triangle in the fourth quadrant, because sine inverse only works in the first and the fourth. So if I type that in my calculator, let's see here, sine inverse of negative 1/3. In degrees, that would be negative 19.5. So theta is approximately negative 19.5 degrees. Now that puts it in the fourth quadrant, but if we're looking between 0 and 360, we're going to want to change that into a positive angle. So I'm going to add 360 degrees to it. So this is the same thing as 340 degrees, 340.5 degrees. So that would be that angle. Now the reference angle over here is 19.5 degrees, and all we're going to have to do to get to it is add 180. So 19.5 plus 180, that'll get us 199.5. Now we got to be careful. This isn't what x is equal to. This is what theta is equal to. So we're going to have to set up the same type of equations as over here. The problem is I'm going to have these answers in degrees. We can always convert them back into radians or vice versa. We're going to have 2x is equal to the smaller one I'll go with, 199.5, plus 360k. And the other one's going to be 2x is equal to 340 degrees, 0.5, plus 360k. And then just go through and divide by 2. So we're going to get x is equal to 99.8 plus 180k. And down here we're going to get x is equal to 170.3 plus 180k. So when we go through and start playing with our answers, we're going to get 99.8 degrees, 170.3 degrees, and then start letting k equal 1, and 2 is not going to work, so k equals 1. 180 plus 99.8. If we let k equal 1, which would be 279.8, and 170.3 plus 180 degrees would be 350.3. So this one also has 4 answers to it. It's just that we had to use the calculator to get to it.